Our first invited speaker of ADAS, actually 2020, that Azalee. I hope I pronounced your name not too terribly. And she will be giving a talk about the Data Carpentry curriculum for the astronomical community. Azalee, you can, I will stop my video, I will get out of your way. And Azalee, whenever you're ready, you can unmute yourself and start your screen share.
Okay, awesome. So first of all, I want to thank you guys so much for inviting me. And this is my first ADAS, so I'm super excited to be here and presenting this work to you. So I want to talk about work that I've been doing in collaboration with the American Institute of Physics, the American Astronomical Society, and the Carpentries community. And this work is developing a data carpentry curriculum for the astronomical community. So I want to start by talking a little bit about the Carpentries. So the Carpentries is an organization that is really founded to look at how do we bring computational and data skills to the scientific community. And so it was originally just software carpentry. This was a set of lessons that was founded in 1998 by Greg Wilson and Brett Gorda to give scientists programming advice, basically, and bring computer science and software engineering to the research community. So out of this, in 2014, grew a data carpentry community and curriculum. And so this was looking not at software skills, but at data skills. And because data is so unique to every domain, every data carpentry lesson is domain specific. And so that's why we're looking at developing a data carpentry curriculum for astronomy, because in astronomy, our data looks different than what data looks like in genomics, and the issues that we struggle with are different. And then the third component of the Carpentries is the library carpentry. And this is looking at informatics and data scientists within libraries. And so these three Carpentries merged in 2018 into the Carpentries. And the Carpentries, I would say, took their current form with the different lesson, the instructor training, around 2012. And since this time, you can see this close to exponential growth. I do want to add the caveat that the dotted line, I just connected the end of 2018 to the current numbers in 2020. So treat that as approximate. But we have close to 3,000 instructors. Over here on the left, you can see a map of where our instructors are worldwide. We also have taught close to 3,000 workshops. And reached close to 75,000 learners. So the Carpentries, in my opinion, have had a huge impact on the scientific community, physics, astronomy, biology, genomics, libraries, like everywhere. And I think there have been a couple key pieces to success. So one of these pieces is thinking about scalability. You've just seen this huge growth that the Carpentries have undergone over the last 8 years. And so part of this is thinking about succession. And I know that Greg thought really carefully about how do I define who comes after me and how the Carpentries are run. There was the formation of the Software Carpentry Foundation. There was a set of bylaws that were created. And then in addition to that, there's the formalization of all of these different procedures, policies, and infrastructure. So there's a mentorship committee, and there is a curriculum committee, and there is a lesson development handbook, and there is a lesson template that all of the different carpentry lessons use. And therefore, when a lesson template update happens, it can be applied to all of the different curricula. So there's just this series of infrastructure. There's a workshop website that and a whole procedure for how to build your workshop website when you're running a workshop. I also think that the Carpentries have been really key in meeting their learners' needs. This was not the first workshop I ever took on Python, but it's the workshop that really fundamentally changed the way I code and how I approach my coding. And I think a lot of that is thinking not about what do computer scientists think the most important thing is? But in talking to researchers and in talking to scientists and asking them, what are the pieces that you wish you had known earlier? Or what is the most efficient way that we can get you doing reproducible research? And then putting that into a 2-day workshop. And then the other piece is thinking about, how do you sell these workshops? If you say, I'm going to teach you best coding practices, you may get some subset of the community. If you say, I'm going to teach you Python, maybe you get a different part of the community. And so really thinking about, how do we sell that? And then how do we sneak in something like shell scripting that people aren't necessarily going to sign up for a workshop, but that is really important when you're talking about kind of reproducible and pipelining research. So another piece that has been really fundamental for me is the community that the Carpentries have built. They've built a diverse and inclusive community. They have a strong emphasis on accessibility. This is seen in the workshop templates, in the checklists that have phrasing and require you to really think about how accessible is my workshop. So this is a picture I'm showing here from Carpentry Con. So this is the first conference looking at for the Carpentries community, and everyone is being the little carpentry guy, or girl. Actually, maybe that should be genderless, the carpentry person. But I think that this is a really great community. It's been very welcoming, and I've had very positive experiences in it. And I think this leads to another really important part of the carpentry functionality, which is collaboration. And voluntary work. So all of the Carpentries, all of the workshops are taught by volunteers. All of the lesson maintenance is done by volunteers. And all of the lessons are on GitHub, and all of this is done via a pull request infrastructure. And so there's this strong emphasis on collaboration and open source work. So all of the lessons are CC BY licensed, and anyone can teach these lessons. And really there's an emphasis on, how do we help each other build better lessons, rather than, well, I'm going to build my lesson over here and you build your lesson over there. And then the final piece that I think is really important is that the instructor training is focused on, how do you teach coding based on research into computational education. And so part of this is hands-on live coding. So the instructor codes along and the learners code with them. And what I've seen from this is that it gives our learners the ability to take what they learn and immediately apply it to their research. So this is what I think makes the Carpentries successful. I can say that the Carpentries fundamentally changed the way I code. So I was really lucky to join in 2012, first as a learner, and then I immediately signed on to do instructor training. And you can see in my coding the day I took software carpentry, because I learned about functions, and that just fundamentally changed the way I code. And I learned about version control, which was a huge step forward to me, because I was in this position. I had done a master's, I had a master's thesis, but I didn't know what version of my code went into my master's thesis. And that always makes me uncomfortable. So version control was just this revolutionary concept to me. And one of these things, I was like, why did no one tell me sooner? I've been coding for 6 years. Since then, at different workshops I've been at, I've become much more comfortable with shell scripting. I've learned SQL. And so all of these are all tools that I now use every day. And that is thanks to Software Carpentry. Beyond just the way I code, Software Carpentry changed, I would say, my life, and has made it richer. So the mission that the Carpentries have about bringing best practices to the scientific community really spoke to me. And it's something that I feel strongly I've benefited from, and that the entire community would benefit from. So part of this that I really appreciate is getting to teach workshops internationally. This has connected me with all different networks, people at the AAS, people, the European Space Agency, went to Edinburgh, I went to Israel, I've taught at SciPy. So all of these different workshops and environments I also, beyond software carpentry, in an attempt to bring this to my UC Davis physics department, created a code review group where we've gone through some of the carpentry workshops, but we also just sit around every week, every 2 weeks, and we look at each other's code. And through this group, I've created this venue to talk about coding in an academic environment where I found that doesn't usually happen. Usually the code is just this means to an end, but we don't really talk about what those means are. I also got to help develop this data science for science curriculum. So this was a graduate level class that was based around data science skills that would be really useful for graduate students. And I was able to apply a lot of the pedagogical skills that I had learned in teaching, as well as the different lessons that I had built and experimented with, and designing some new ones for this course. And then finally, this brought me to what I'm here to speak with you today about, which is the data carpentry curriculum. So this curriculum came out of a collaboration between me and Rodolfo Montes, and we met each other in organizing the software carpentry workshops at the American Astronomical Society winter meeting. And we worked on these for about 2 years. And then he approached me and said, hey, I think we should submit a proposal to the American Institute of Physics Venture Partnership Grant to develop this data carpentry curriculum. And so this is a partnership between the member society, which in this case is the American Astronomical Society, and the American Institute of Physics. And then we brought in the Carpentries as well through connections that I had with the Carpentries for this coalition of different organizations. Also, we created an astronomy curriculum development committee. So in addition to Rudy and myself, we have Phil Rosenfield, who is with Microsoft Research, Brett Morris, who's a postdoc. Aaron Becker is the associate director of the Carpentries and the head of the curriculum development team. And then Diane Frendak works at the AAS, and Susan White works at the AIP. So this is our advisory group. We are looking at the lessons and figuring out how to bring this curriculum forward. And the first question that we asked is, what is a data carpentry curriculum for astronomy? And so the first thing that we decided is to deviate from the typical Carpentries curriculum, or the typical data carpentry curriculum, which focuses on learners who are just starting to program and are maybe moving from doing things by hand in Excel to automating tasks. And we felt like the astronomical community, by and large, is doing this, and that we wanted people who were maybe had the skill levels that they had already acquired in a software carpentry workshop, and we wanted this to be the next level workshop. So we assume that our learners can navigate the shell and have a basic working knowledge of Python up to writing functions in Python. Additionally, in defining this and in defining what is the next step to software carpentry, it was really easy to get lost in all of these different directions that we could go in. So we could think about teaching a pipelining workflow for cloud computing, or we could think about teaching an open source version control workflow. But we decided to really focus in on the data, partially guided by some of the advice in the data carpentry lesson development requirements, and focus on what data sets do we want to use and what do we really want to teach the astronomical community about handling data that we're seeing now and that we will need, skills we will need for the future. And then finally, as this is being run partially through the AAS, we wanted to think about what workshops currently exist and what workshops and what skill sets aren't currently being taught. And so with this in mind, we developed a lesson structure that had 3 different components. The first was thinking about data management. And under this, we were thinking about maintaining metadata and information on your data, thinking about the provenance, where your data came from, and versioning your data. How do you keep your raw data raw? And then how do you have different versions that you can potentially move between? And then we also thought this might be a great place to kind of take people's Python knowledge to the next level, look at classes and how you can use these really effectively to read in different data and handle your specific data format. The next piece we wanted to include was a piece on interactive data visualization. Looking towards the future, we see these high dimensional data sets, and how do we explore these data sets and find trends in all of the noise and all of the different dimensions. And then the third piece was thinking about publishing results in two platforms. One was the AAS publishing, and thinking about how could we introduce our learners to the AAS capabilities of interactive figures. And then also looking forward to self-promotion, leaving academia, publishing results on the web in, again, an interactive form, maybe spinning up a Heroku instance or something like that. So with this basic outline of what we wanted our lessons to be, we decided it was time to hire a lesson developer. And so this is where the bulk of our funding is going, is to paying a lesson developer. And I thought it was really important to pay a lesson developer because this is, the Carpentries estimate it takes about 500 hours of work to develop a curriculum. And I felt that everyone is so oversubscribed, it would be really hard to get this curriculum off the ground without someone who had time devoted to do this. And then the other key piece to this is that we wanted this position to be a part-time position, because all of the people who are collaborating with the lesson development developer, the entire curriculum committee, are all volunteering time and can't devote many hours a week to this. And so we wanted to allow time to review so that it could be an iterative process, and it wasn't just the developer doing the full development and then leaving and then, us reviewing the lesson. So we put out an ad for a developer, we interviewed people, and ultimately we chose Alan Downey. Alan has degrees in engineering and computer science. He's a professor at Olin College. Importantly, he had been trained as a Carpentries instructor, and so this meant that he had knowledge of both how the Carpentries functioned and the ethos of the different lessons and the pedagogy. And he's written a number of different books on Python, on statistics, and has given a number of different workshops on this in addition to teaching. So he had a lot of lesson development experience. And we felt, as the curriculum committee, we had enough astronomical knowledge that we could kind of combine our powers to develop these lessons. So with our lesson developer on board, we next had to choose a data set. And so the most important pieces of this were choosing a data set that was easy to explain scientifically. We didn't want really area-specific jargon. We wanted this to be something that we could explain to any astronomer. And we wanted skills that could be easily extended to different data sets and different disciplines. So this was part of our proposal, was to develop a curriculum for astronomy, but that could be adopted by other AIP member societies and extended into their disciplines. So the different data sets that we looked at transient data sets. So I study supernovae. This is my wheelhouse. And I have seen my community move to needing to do database queries and needing to do automatic processing. And so those were the data sets that came to mind first to me. We also thought about a color magnitude diagram. There are different axes you can look at for this. And we had developed a prototype SQL lesson for our software carpentry workshops using the Hipparcos database. And then we also thought about the angst survey as a potential data set for this. We also thought about looking at stellar streams in the Milky Way. So this is using the Gaia data set, data release 2. Looking at time series, different star spots. This was something that Brett had developed some lessons for. And then looking at multi-wavelengths. So Rudy does X-ray astronomy. I do a lot of optical astronomy, and we were thinking about how do we, look at the high energy database and correlate that with something like an optical database to get a full spectrum of some object. So we investigated all of these. We thought about how could we possibly manipulate this data? What would our carpentry lesson look like? And we ultimately chose the stellar streams using both the Gaia Data Release 2 databases and the Pan-STARRS dataset. And the lesson we developed is based on a paper in 2008 by Adrian Price-Whelan and Anna Banaka called Off the Beaten Path, Gaia Reveals GD1 Stars Outside of the Mainstream. And so the science here are hopefully easy to understand. Science is that you have a globular cluster or a dwarf galaxy or some kind of compact object that gets too close to the Milky Way and gets tidally pulled apart by the Milky Way's gravitational potential. And so this creates a stream of stars that all have kind of a similar motion in a similar direction because they're all coming from the same source that's getting stripped out. And so that's what you can see here in these figures is this galaxy passing through the Milky Way and leaving this big stellar stream. And that's what we will be ultimately identifying from the Gaia Data Release 2 is a stream like this. So we quickly realized in starting to develop this that we had a way too ambitious plan and that it wasn't going to fit into a 2-day workshop. So we narrowed the scope of our workshop to looking at data management and using Python and SQL to access remote databases. And so this is both the Gaia and the Pan-STARRS database. And then combining the data visualization and publishing into a lesson on creating a compelling publication quality figure. So what are the different matplotlib tricks that give you things like latex symbols, or what do you think about in terms of how to visualize your data set so that your audience can see what you want them to see? And we chose to focus the lesson on this figure. So this is figure 1 from the paper. And I want to talk to you a little bit about what's going on. So in the upper right-hand corner, we have a proper motion plot. So proper motion in right ascension and proper motion in declination. And you can see this part that's highlighted in orange is what we think is this abnormal cluster of stars that are part of this stellar stream. And they all have almost no motion in one direction and then high proper motion in the other direction, in the phi 1 direction. So if you take these stars that are highlighted in orange and you plot their position on the sky, that's what's being shown in the upper left-hand corner. And you can start to see this dark stripe coming out, and that is our stellar stream. But to really weed out a lot of these foreground stars that are contaminating the data, if we join the Gaia database with the Pan-STARRS database, we can look at the Pan-STARRS photometry. And so when we build a color magnitude diagram of this, that's what's shown in the lower right-hand corner. This cluster of stars that's highlighted here in orange stands out. And this can be fit by a model of stars that have the same metallicity and the same age. So you can fit this with an isochrone, and that's what's being shown here in red. And if we use the orange and we choose these stars, just these stars that are along this isochrone, then you get the plot in the lower left-hand corner. And here the GD1 stream is really standing out. And what you see here is that their structure. So this paper for the first time identified a potential progenitor globular cluster to this stellar stream. It also showed substructure, which tells us about substructure in the dark matter halo of the Milky Way. And this is all from doing these joins and filtering of the database. So this is the main point of our lesson is reproducing this figure and then talking about the different ways in which this visualization is successful or unsuccessful. So the final results of the workshop, it covers writing queries to remote databases. We use the AstroPy affiliated Astro Query package for this. We look at our results both as AstroPy tables and as pandas data frames. So this gives our users experience and with both of these, looking at columns and tables and series. It uses AstroPi coordinates and AstroPi units, which are both fundamental to all areas of astronomy. And we look at when should you save your results, and looking at saving them in different file formats, both FITS, which I would say is kind of the current standard, and HDF5, which is a potential future standard. It's also something that I've seen a lot of simulations saved in. Looking at filtering and joining databases, and then all of the visualization is done in Matplotlib. And so I want to leave you with where we are in this development process. So the lessons are almost completely done. We have our pilot next week, starting November 16th. And so this is going to be an extended time workshop where we're interspersing the teaching with a lot of feedback from our learners. So after we do this pilot, we then are going to incorporate the feedback and all of the lessons that we learned from this workshop and put this into our first 2-day workshop, which will be at the winter meeting of the American Astronomical Society in January. At that point, the lessons should be basically done. We'll do some final tweaks, and then we'll port them from their current format, which is a Jupyter Notebook format, into the Carpentries lesson template. And we hope to have these released in early spring 2021. At that point, we'll define our lesson maintainers, and we'll start to train instructors so we can really get this lesson out to the astronomical community. And then we hope at this point that these lessons can be adopted by different disciplines and for different data sets. So I'd like to leave you with 3 different URLs, and I will throw these into the Discord channel after this talk as well, so you don't need to write these down right now. But the first is a mailing list. If you want updates on the status of this curriculum when we're soliciting feedback from the community, please subscribe to our mailing list. The set of working notebooks right now is on Alan's GitHub. It's very well fleshed out. There's a lot of explanation there. So that is our current state of the lessons. And then ultimately, once these are put into the Carpentries lesson format, they'll be at this final location, the Data Carpentry GitHub. So with that, I'd like to say thank you, and I'm happy to take questions.
All right, well, thank you so much. That was a fantastic presentation, very inspiring work, I will say. You know, I've seen some of your carpentry lessons on the web, and they are all top notch. I mean, everything from basic Python. I haven't seen the Data Carpentry yet, but I would be very interested to check it out. And I always find that if you have to teach something to somebody else, go to the Carpentry website first, because you're going to find amazing stuff. Now, we have a couple of questions, so I will read them for you. So we have a question: is it possible for anyone to attend any of the future online workshops?
Okay, so for the pilot, we limited attendance, and I think the Carpentries in general are recommending limiting attendance to around 20 people. About a week ago, I checked in on the AAS workshop, and that workshop only had maybe 7 or 8 people registered, so I believe there's still room in that workshop. Those are the only workshops we have planned, but we hope to have many more. And I would say, like, yes, anyone can attend the workshops. It's a matter of hearing about them and signing up. Once we get the curriculum finished and we've trained more instructors, I hope that we will be able to meet the demand for the workshops.
Awesome. Another question, do you plan to develop more astronomy lessons for the other data sets and themes?
Oh, no, I'm hoping you do that. I guess potentially the transients I would be interested in, but right now that is not my focus. I think trying to get this out, and you know, I will say that in developing these lessons, one of the things that we've really tried to focus on is having skills that are broadly applicable to any field. So if you looked at the list of skills, using Astro Query, writing SQL queries, these are all important skills, not just if you do, galactic astronomy and study stellar streams, but that you could apply to any of these other data sets. And that's really a goal of ours with these curricula.
Fantastic. Well, thank you again for your fantastic presentation. Thank you again for the very inspiring work, by the way. We are very honored to have you as the first invited speaker for ADAS. I think you had a great talk, a great opening for ADAS, and thank you so much for your time.